All right, welcome back. This is video C8, Algebra creates candidates. So the learning goal today is be able to solve an equation, treating those algebraic answers as candidates, and decide which candidates are actual solutions by checking the original equation. If you're going to take one thing away from today's video, it's just going to be any solutions that you find better work in the original equation, not some equation you made along the way through algebraic manipulation, the original equation. So we're gonna, as always, we're gonna jump right in with a hook, and this hook is woven right into the I do. So you can see, here's our first question. Square root of x plus 5 equals x minus 1. I'm going to tell you the algebra is going to give us two answers. Our question is, should both count? So your hook here, before starting, what restrictions or what warning signs do you see? Said another way, before we do any algebra, what has to be true for this equation to make sense? And after we square it, why should we be suspicious? So I'm gonna attack this question the way most of us would. We're gonna say, well, okay, the thing we see is the radical, and I know a radicand. We've talked about this in videos. The radicand has to be non-negative. Okay, so by that logic, we're gonna say x plus 5 has to be non-negative, so x has to be at least negative 5. If x is at least negative 5, we're probably happy with our answer. And let's go with that solution strategy. So to solve it, this isn't a solving radical video. You can check out the kind of skill videos if you'd like to see that. But solving this thing, I know I'm going to isolate a radical and I'm going to square both sides to remove it. As I do that, I am making sure that I properly expand the right side to include that middle term. So I get x plus 5 equals x squared minus 2x plus 1. Clear out one side with a 0. X squared minus 3x minus 4. And I'm going to factor that x minus 4x plus 1. And then that kind of feeds me x equals 4 or negative 1. Now, personally, I'm looking at those answers, and those both look okay. Like they're both bigger than negative 5. That's good. It's really tempting to just box these up and move on because it's kind of an ongoing message. Like we want to be fast, we want to be efficient. Is checking this efficient? Let's check it and find out. So let's just take that minute and check it. So let's first check x equals 4. So in the original equation, and again, this is what I mean. I'm checking in the original equation, not some kind of pathway, some middle step. I'm checking in the original equation. So let's do it. So if I check x equals 4, I'm going to get square root of 4 plus 5 is maybe equal to 4 minus 1. So square root of 9 is maybe equal to 3, and 3 is 3. Notice that root is positive because I didn't put the root in there, so it's implied positive principal root. 3 equals 3, yeah. So 4 is good. We're happy with x equals 4. Let's check negative 1. Now, and you can kind of see, the way I'm saying this, you can probably see there's going to be a problem with negative 1, even though we didn't think there would be. So if I jump in here, negative 1 plus 5 under a root may be equal to negative 1 minus 1. So that's root 4 may be equal to negative 2. Well, no. Root 4 is 2. 2 is not equal to negative 2. So that's a rejection. Now, for me, what I would do then is I would go back up here and I would cross out that option. Or you can kind of rewrite it. Okay, so x is just 4. I'm going to drop the negative 1, and that's what we're going to box it up. Now, you should be thinking, so like I'm going to hit the pause prompt in here. Why did that not work, right? Like the algebra just gave us the answers. Why did it not work? And that's the point of this video. Is the algebra is not giving us the solutions. It's giving us candidates for the solutions. You're not done once after the algebra. You do have to make sure they work in the original equation. Let's go back and say, why didn't that one work? Well, negative 1, we focus on the left side. But the other thing we know about the radical is when I have a radical, I know that this has to be positive. So if I equal, let's say smiley face equal sad face, I know if I square root a positive number, I have to get a positive. So I know that right side also has to be positive. So if I kind of go back in here, well, that tells me that x minus 1 has to also be positive. So x has to be at least 1. And I can see that that negative 1 kind of contradicts that. So that's the issue. You could think of it like that, or again, you could just make sure you're checking in the original equation. Okay, let's try another one. So I went too far. So here is your first you do. So again, you can see the prompt, pretty simple prompt there. Solve and check, square root of x plus 1 equals x minus 1. So again, I'm going to get you to pause. And the question is, what restriction do you notice before squaring? Try it. And then again, remember that the algebra is just giving you candidates here. It's not giving you a locked and loaded answer. It's just saying here, what's the possibilities? So again, pause this, take a shot, and then we will come back and talk about it. Okay. So take a look at this one again. I solved it a very similar way. I'm going to square both sides. I'm going to get 0 and 3. I'm going to check on the original. And I see that the 0 doesn't work. I'm going to keep the 3, reject the 0. If you are thinking, kind of a more generic strategy, it's again that we know that the left-hand side, sorry, I'm still my highlighter. I know that the x plus 1 has to be at least 0, so x has to be at least negative 1, but also x minus 1 has to be at least 0, so x has to be at least 1, and that's the one that rejects the 0. Again, either way you want to think of it, just make sure that you are checking to make sure all candidates are real solutions. Okay, so let's move on to I do 2, just a rational equation this time. So we see this equation, 2 over x minus 1 equals x plus 1 over x squared minus 1. So first thing we can see, factor first and list those non-permissible values. So I have 2 over x minus 1 equals x plus 1 over x plus 1, x minus 1. Now I do have an option here. I see I could reduce that right-hand side, but maybe I didn't see that. So I might even do this question both ways and just kind of talk about what we see. So let's pretend we didn't see that reduction. We're going to say, okay, x cannot be plus or minus 1. Now, when I go to solve it, what I'm going to say is, well, okay, I'm going to multiply through by the denominators. So I'm going to multiply through by the x plus 1, x minus 1. So on the left here, I'm going to get 2 times x plus 1 because the x minus 1 is divided out. On the right, I'm going to get x plus 1 because the x plus 1, x minus 1 divides out. So what that's going to give me is 2x plus 2 equals x plus 1. Subtract the x, subtract the 2, x equals negative 1. But we said that x cannot be negative 1, so we immediately discard that answer, right? So that's the candidate. X equals negative 1 is the candidate, but when we check it against the original restrictions, we're going to say, well, x cannot be negative 1. So we go back up and reject it, and then we say, okay, so we had the one solution, but we just rejected it, so therefore no solution. Now here's a neat little thing. If I change colors, what if I do that question? What if I had reduced it? Would that have fixed my problem? So in that case, I would have 2 over x minus 1 equals x plus 1 over x minus 1, x plus 1. But if x plus 1 divides out, that's going to leave 2 over x minus 1 equals 1 over x minus 1. If I multiply through by x minus 1, I get 2x minus 1 equals x minus 1. So 2x minus 2 equals x minus 1, x equals 1. It's a different answer, but again, I see, well, x cannot be 1, so therefore I end up in the same place, that no solution. So either way you go, you are going to get that no solution. The nice thing with the rationals is just a couple specific values you have to check. So I like factoring, and I'm just going to look at what are my kind of no-goes. And if one of those numbers pops up, I'm going to say, well, that's not allowed. because, again, it was not allowed in the original equation. So last one for you to do there. You can see at the bottom of the screen, x over x minus 2 equals 2 over x minus 2. So solve that, check it, and again, keeping in mind that your solve is just finding the candidates, not necessarily your final solutions. So see, I note that non-permissible is x can't be 2. When I go to solve it, I do see that is my answer, x can't be 2. So therefore, I'm going to say, well, x cannot be 2. So what I'm really doing is I'm just going back, I'm just going to cross it out. I'm going to say there's no solution, right? I had the one option. That one option doesn't work out. There's no options. That's it. Okay. Quick checklist to end this off with. Remember, you're going to start with your original equation, right? That's the equation you're given, the equation you find. That's the one that you need to satisfy your solutions into. Make sure you kind of write the restrictions down somewhere. That's more important for the rationals versus like a radical equation, but we'll see. Solve algebraically, and remember those results are just candidates. You need to kind of realize, like, do we have a function that's going to have domain restrictions? That's like a rational, radical. Notice I didn't do a polynomial here because I'm never worried about a polynomial, right? Like a quadratic, I don't need to check the x. The x is going to work unless it's some kind of word question. And then again, just reject those answers that make the original equation false, and then write your final solution set. If there's no answer, there's no answer. That's okay. And that's it. Thanks for watching.